The purpose of ARP is to provide the MAC address to the sending node that corresponds to the IP address, so the information can be correctly sent. ARP provides two basic functions. First one, resolving IP addresses to MAC addresses. And second one, maintaining a table of mappings called ARP cache. ARP cache is used to find the data link layer address that is mapped to the destination IP address. This happens when a packet is sent to the data link layer and needs to be encapsulated into a frame. Layer 2 broadcasts to all devices on the Ethernet LAN to know which one has a known IP address. The node that matches the IP address in the broadcast will reply. When the sending node receives the MAC address of the destination, it adds the MAC address and IP address to the cache or map. After the sending node gets the corresponding MAC address, it forwards the information to the destination. In switching, we must know that a central device connects various end devices on most Ethernet networks. A Layer 2 LAN performs switching and filtering based on MAC addresses. The LAN builds a MAC table to make decisions. A switch is a device that uses the MAC address to direct network communications through a port to a destination node. It determines how to handle incoming data frames by using the MAC address table. The switch receives a broadcast frame from PC1 on port 1. The switch enters the source MAC address on the switch port that received the frame into the address table. Because the destination address is a broadcast, the switch floods the frame to all ports except the port on which it received the frame. The destination device replies the broadcast with a unicast frame address to PC1. The switch enters the source MAC address of PC2 and the port number of the switch port that received the frame into the address table. The switch can now forward frames between source and destination devices without flooding. The switch has some basic settings known as duplex settings. It has to be the communication is directional by direction. These settings are called half duplex and full duplex. Half duplex communication means that the sending and receiving data don't occur at the same time. On the other hand, full duplex means that sending and receiving data occur at the same time. It is also necessary to have the correct type of cable for each port. The connections among switches, hubs and routers require specific cables. Now most devices use the Auto MDX feature. There are two frame forwarding methods, store and forward and cut-through. In store and forward switching, when the switch receives the frame, it stores the data in buffers until the complete frame has been received. In cut-through, the switch acts upon the data as soon as it is received, even if the transmission is not complete. Forward switching has the lowest level of latency and is the most typically used. Fragment-free switching stores the first 64 bytes of the frame for forwarding. Switches use two memory buffer techniques, port-based and shared memory. Port-based frames are stored in queues that are linked to specific incoming and outgoing ports. Shared memory buffering deposits all frames into a common memory buffer, which all the ports on the switch share. Fixed configuration features or options cannot be added to the switch beyond those that originally came with the switch, while modular switches offer more flexibility in their configuration. The major types of Layer 3 interfaces are Switch Virtual Interface, the Router Port, and Layer 3 Ether Channel.
created using Powtoon.